G'day again. Last video for differential equations, and this video is on slope fields, or also known as like direction fields. Okay. And again, this is another method that is used by scientists and mathematicians to get a feel of what the solution for something might look like when they can't actually integrate or can't solve a DE. There's so many D's that can't be solved, and so we need different ways of doing it to approximate. And what it basically says is that if you have some dy dx equals to some, I think the best thing just to do an example. Let's just do an example. Dy by dx is equal to x. What this says is it says that the slope of the graph y against x is equal to the value of x. And so what we can do is, I'll just quickly show you, is that what we do is we just take one point at a time. We look at each point on a grid, and we look at each point and decide what the slope is at that point. Okay, so I might just do a few here sort of thing, just really quickly. I'll do a proper example in a second. So what we're saying, let's have a look at 0, 0. When x is equal to 0 and y is equal to 0, what is the slope equal to? Well, the slope is equal to 0 because x is equal to 0. And so what we do, remember, a slope of 0 is just a horizontal line. So we just draw a little horizontal line there. What would it be at 1, 1? When x is equal to 1 and y is equal to 1? Well, that would be equal to 1. What does the slope of 1 look like? It would be something like that. Okay, and in fact I can sort of take shortcuts here because you see how the y value doesn't affect it at all, and so it means it doesn't matter what the y value is. And so in fact all of these, whenever x is equal to 0, the slope will be equal to 0. So all of those will be like that. Doesn't matter where it is on that. And in fact also when x is equal to 1, you're going to get a slope of 1. Something like that. Okay, like that. How about let's do 2, when x is equal to 2. When x is equal to 2, the slope is equal to 2, and so we do it like a steeper one in there, and it'll be for every single one. Okay. And how about x is equal to 3? Again, if x is equal to 3, the slope is equal to 3, and so it'll be steeper again, so it'll look like something like that. And it just gets steeper and steeper the further you get out, and eventually it'll just be infinity and it'll be straight up like that. What would happen if you went to the negative side? So if x is equal to -1 here, if x is equal to -1, your slope is equal to -1, and so at all of these points your slope of -1 looks like that. And so what we're just doing at every point that we're asked to, we're just drawing these in. Slope of -2 here, and it'll look like -2s. It's steep, like that. You get the idea, I think. That what we're just doing is we're just drawing in the slope at each point. Because we can't solve this DE, we can solve this, but assuming we can't solve that, then what we do is we just draw every coordinate, xy coordinate, we're drawing in a tiny little slope or direction of where the graph goes. Now, what this shows us is that you can sort of follow the lines to see what the solution will be. Okay, so I'll choose a couple of different colors, and let's just start here. If we started here and followed that slope, let's just keep going and follow that slope. It gets to here, it evens out, gets to there, evens out. By here it's flat, and so we keep going, and then it pushes us up and then pushes us up in that direction. And so that is one solution of this slope field. That's just one solution. Okay, and it could also be, let's just choose another point. Let's choose to start from here. Let's choose that point there. Let's start from there. We go across, we hit that, and it sort of pushes us up in that direction, pushes us up, and goes like that. If we go back in here, it pushes us up in that direction, pushes us up, and goes like that. And so there's another solution in this. And so what we need to do to find a particular solution is to have a given point on here where we will get one solution. So that's what I thought. When I chose that point there, that was a given point. If you're given that a point 0, negative 4, 0, negative 3, then that will give you this particular solution with this green line. Okay. If you chose the point we think we chose that point there, so negative 2 and 5 or something like that, that gives you this particular solution here. So that's how we use slope fields to find solutions to DEs when we can't actually use calculus to find solutions. Let's just have a look at this. We can solve this. Y is equal to the integral of x dx, which is equal to half x squared plus c. And that's exactly what we have here. We've got x squareds, we've got our parabolas in there, and the plus c is our general solution, and that means that those graphs just move up and down. So they're all our different types of solutions. We need to pick a particular point, so 0, negative 3. We choose a particular point that will give us the value of the c, and then gives us that. And so that's what's going on here. I'll just do probably a bit more accurate example, but that's basically all we're talking about here. So let's get something going here. Let's just do another example. If we want to sketch the solution or the slope field for dy by dx is equal to, how about x plus y? Let's have a look at that. So at the moment we don't know how to integrate this, and so that's an example of one that would be interesting for us. So I'm just going to label some points on here. So 1, 2, 3, 4. So every 2. Okay. Sorry to take up some time doing this. 3, 4, etc. So and let's choose a bunch of points. Okay. I'll do them in red. Red's probably casting light. Blue. Let's go blue. So at the point 0, 0, what's the gradient at 0, 0? 0 plus 0 is 0, so you're going to get flat line. It didn't go blue. Go pink. So you're going to get flat line there. So a gradient of 0 out there. What about at the point 1, 0? You're going to get a gradient of 1. So it's going to sort of go up like that. How about at 2, 0? You're going to get a gradient of 2. So it's going to be pretty steep, and you can see what's happening. It's just getting steeper and steeper as we go across. How about negative 1, 0? Well, it's going to be a gradient of negative 1. At negative 2, 0, it's going to be steep, steeper, etc. So there are all those points there. And depending on the question, usually it just gets you to do a handful of these in an exam or something like that. But let's do another one. What about 0, 1? That's going to have a slope of 1. Like that. 0, 2, gradient of 2. 0, 3, gradient of 3, etc. And then negative 1 will be negative 1 there. Negative 2 will be that line there. And that line, so it's going to get steeper and steeper the more you go down like that. Okay, let's have a look at 1, 1. At the point 1, 1, what will the gradient be? 1 plus 1 is 2, so you get a gradient of 2. How about at 2, 1, you get a gradient of 3. And so again, they're just getting steeper and steeper the more you go across. So they're positive, really steep, really steep, really steep, really steep, going that way. Okay. Down here, 1, negative 1 is 0, so they'll cancel out. And in fact, everything along here will be 0. So straight lines along there. Straight line, straight line, straight line. Okay. I'll just do a couple here to show you. I'm not going to do all of them. Negative 1, negative 1, we get a gradient of negative 2. It's terrible. Negative 2. Negative 2, negative 1, you get steeper. So these just get steeper again. Like that. Steeper, steeper, steeper. And so you end up getting this. And if you grab a pen and you have a look at what the solution might be, this one is a bit tricky. I'd have to probably draw some more in there to fully understand what the solution would be, and you could have a look at it yourself. But if you start from there, it comes down and it flattens out. And where does it go from here? It looks like it probably gets pushed up that way, but I'm not sure. The other thing is that if you come up from this way, it looks like it gets pushed in that direction. So it might be asymptotic in its behaviour. So I'm not sure. But that's how you do the slope field. You just do a point at a time, find the derivative, and then roughly sketch the slope on there. And then to find a particular solution, start at a point and then draw following the slopes of the curves. Okay, and that's how you do them. I'll go through that more thoroughly in class.